we said rational tastes are those that are complete and transitive. We now want to look at three more assumptions that can help to simplify our model of tastes. Now, rationality does not depend upon these assumptions, but they are still important, right? So we're going to look at three assumptions. The first is going to be the property of monotonicity. Now, tastes satisfy monotonicity. So now tastes satisfy monotonicity if they're such that if they're such that more is better than less, or at least not worse than less. Right, so that is when monotonicity satisfies. So monotonicity is the idea that more is better than less, or at least not worse than less. Now, what is the implications of the monotonicity property? Let's look at first implication. Now that we're looking at this says that if a bundle contains more of all goods, so you have two bundles, one bundle has more of all goods than a second bundle. And then given monotonic tastes, a consumer strictly prefers that bundle. So if I had one bundle, so let's say we're looking at bundles of two goods. We had bundle A, which had 1 and 3, and we have bundle B. Let me just make it a little sorry, let me just change its thickness a bit. So we have bundle A, which is made up of 1 units of good 1 and 3 units of good 2. And we have bundle B, which is made up of say 4 units of good 1 and 6 units of good 2. So basically, what monotonicity property says is that we have a bundle B which has more of both goods because we're looking at just two goods, then a second bundle. Then if the property of monotonicity is satisfied, if tastes are monotonic, then a consumer strictly prefers the bundle which has more of all goods. So given monotonic tastes, B is at least as good. B is strictly better than A. Given monotonic taste, B is strictly better than A. In this example, graphically we can see if we compare bundles E and C, we can see that E has more of both x1, like this is the x1 amounts that E has, and this is the x1 amount C has, and this is the x2 amount C has, and this is the x2 amount C has. So we can clearly see that bundle E has more of both goods x1 and x2 than C. So given monotonic tastes, E is strictly preferred to C. So monotonicity assumption, if this is satisfied, if your tastes are monotonic, so if you have two bundles and one bundle has more of all goods, then you strictly prefer that bundle. What if a bundle contains more of at least some goods, but no less of any of the other goods than a second bundle? What this means is, okay, let's now compare these two bundles. Let's say, so we're now looking at this part. Let's see, we have bundle A again, which has a 1 unit a good one and 3 units a good two. And we have a bundle B, which has 1 unit a good one as well, but it has 5 units a good two. So it has more of some goods, which in this case is good two, but it doesn't have less of any other good. Means it's basically bundle B has basically has more of one good and has at least the same amount as the other goods, right? So basically, it should not have less than bundle A, right? So in that case, where a bundle contains more of at least some goods, in this case, good two, but no less of any of the other goods. But it doesn't have more of good one, but it doesn't have less than good one. So basically, all the goods in bundle B are greater than all the quantities of the goods in bundle B are greater than equal to the quantity of goods in bundle A. Right, so what you're saying over here is that you have more of good two and you don't have less of any of the other good. You don't have more of good one, but you don't have less of good one, and you have the same amount as good one. So in the case where you don't have more of all, but you don't uh, so basically another way to phrase it is that you have two bundles. One bundle has more of some goods and the same amount of other goods. So in that case, but then what we'll say is, then we'll say in this case, okay, B is at least as good as A, right? So monotonicity says that if there are two bundles and one has clearly more of all, then it is strictly preferred to the other bundle. But if one has more of some goods and the same amount of the other goods, then it is at least as good as. So this is what monotonicity says. So in that case, we use at least as good as. Right, so in the diagram, if we compare bundles B and C, so we can see that B and C have the same amount of x2, but C has more of x1. So by if they satisfy monotonicity, then monotonicity says that C is at least as good as B, right? So this is what monotonicity implies. If monotonicity assumption is satisfied and you're comparing two bundles, one bundle has more of all goods, then that bundle is strictly preferred to the other bundle. If one bundle has more of some goods but the same amount of other goods, then in that case, it's at least as good as the other bundle. So this is for this. Now, but what if can now let's see, can we use the monotonicity assumption to compare bundles A and D? If we want to see, okay, can we use the monotonicity assumption to compare bundles A and D? Now notice A has more of x1, but D has more of x2, right? A has more of x1, but D has more of x2. So in this case, we cannot use the monotonicity assumption to relate bundles A and D because no bundle has clearly more, right? You have one bundle which has 1 5, and you have another bundle. Okay, so this is not the bundles over here. This is just a generic example. This is not related to this graph. Say this has 4 and 2. So here A has more of x2, right? But B has more of x1. So no bundle has clearly more. Monotonicity tells us it could be that one has more of both. So in that case, that bundle is strictly better than the other bundle. One has more of some, but the same amount of other. It doesn't have less of any of the other good. In that case, we can relate them using at least as good as. But here the problem is that A has more of x2, but B has more of x1. So no bundle has clearly more. So we cannot use the monotonicity assumption to relate them.